Hello friends, welcome to another session on learning Python the easy way. This is Esther Hannah, and in today's session we are going to learn what algorithms are. In this video you will be studying the importance of algorithms and how essential it is to know what algorithms are before we start learning Python. So let's get started. What are we going to learn now? We are going to learn what an algorithm is and what are the most important building blocks of algorithms. The most important building blocks of algorithms are statements, state, control flow, and functions. So come on, let's see what they are. An algorithm is a well-defined computational procedure consisting of a set of instructions that takes some value or a set of values as input and produces one or more values as output. It is also defined as a sequence of instructions that describe a method for solving a problem. Definitely, it is nothing but a step-by-step procedure for solving any given problem. So an algorithm takes an input, gives an output. So let's see how an algorithm is able to produce an output by taking an input. The properties of an algorithm. An algorithm written for any problem should follow some of these properties and rules. It should be written in simple English, which is easy to be read and understood and helps in easy conversion from an algorithm to a code. Each and every instruction has to be precise and unambiguous. There should be no confusion in an algorithm. Instructions in an algorithm should not be repeated infinitely. And definitely an algorithm should have finite number of steps. It shouldn't go on and on and on. It should have an end point. And an algorithm should terminate after producing the output, which is in other words called the derived results. So the qualities of a good algorithm. Don't worry when you are asked to find out if a given algorithm is good or not. We have three simple tricks to find out if an algorithm is good. Number one, an algorithm is good if it consumes some amount of time. Which one is lesser, that algorithm is better. So the lesser the time the algorithm takes, better the algorithm. Number two, identify how much of memory the algorithm is occupying. If it occupies less memory, better the algorithm. Number three, the third check is look for its accuracy. Given a problem, there could be more than one algorithm to solve the problem. But please remember and ensure that the algorithm provides you the accurate result and definitely not an approximate result. So an algorithm which gives you an accurate result is definitely much better and good than an algorithm that gives you an appropriate or an approximate result. So next time you're asked to judge the quality of an algorithm, just think about these 3 points: time, memory, and accuracy of the algorithm. So some important characteristics of an algorithm. Number one, the precision. How the different steps are precisely stated or defined in the algorithm. There has to be uniqueness in the algorithm. Every step in the algorithm has to be uniquely defined. and hence should depend on the previous steps. Already we've seen that finiteness is an important aspect of an algorithm, and hence an algorithm should stop after a definite number of steps. Number 4, another important characteristics of a good algorithm is its effectiveness. It should be most effective in solving a given problem. An algorithm should accept an input. An algorithm should produce an output. And finally, an algorithm should possess generality. So coming to the building blocks of algorithms. There are 4 important building blocks of an algorithm. Number 1, statements. Number 2, state. Number 3, control flow. And number 4, functions. Let's quickly see what they are. So what are statements? Statements are simple sentences written in the algorithm. Statements could be assignment statements, input statements, output statements, comment statements, processing statements, and so on. So any computer statement for that matter should include some of these actions. So what are the actions? Input is an action, process is an action, and output is also another action. So these 3 important actions are represented as statements in an algorithm. So let's see a few examples of this. To get an input, we can use a statement like this: read the value of A. To assign or add 2 numbers and store them in a variable, we can use a statement like this: calculate C is equal to A plus B. This is an assignment statement. In order to print the output of a statement, you can say print the value of C, where C is the output of the algorithm. So that's going to be an output statement. So these are simple statements. These statements form the algorithm. And definitely there can be comment statements. So as you can see in this example, read the value of A, and then there is 2 slashes or backslashes. So this represents that the comment statement is present, which tells what is the purpose of that particular line. So here I have mentioned this is an input statement. For the second statement I have mentioned this is an assignment statement. So these are comment statements. So seeing what statements are, let's see what are states. States are nothing but transition from one process to another process under a specified condition within a particular time. An algorithm is deterministic and accomplishes a particular goal given an initial state. We've already seen an algorithm should produce an output and should have an end state. So initially there is an initial state and it processes and finally comes to an end state. So start state and end state are 2 important states that an algorithm goes through. So what are control flow? How these statements help in converting the input to an output is called the process. The process can be done in using 3 different statements or in 3 different ways. So this flow is called the control flow. How execution happens, and it can happen in 3 different ways, and they can be represented as sequence, selection and iteration within an algorithm. So what is a sequence? The word sequence is not new to us. Sequence says one after another, in order, one behind the other. So these are some of the statements that we make use of sequence. So let's take a look at this example that is shown to you. Finding the sum of 2 numbers. So here there are 6 steps. Step number 1 is start. So an algorithm should have a start and a stop. So step number 1 and step number 6 are mandatory ones. And step number 2 says read the value of A, because we want to add two numbers. And then step number 3 says read the value of B. So these two steps 2, 3 get the input. Step number 4 is actually the processing. Calculate sum is equal to A plus B. So A and B should be added and stored in the variable sum. And in step 5, print the sum of two numbers. So that is the output statement. So this is an example of a sequence where line by line execution happens one after the other, right from step number 1 to step number 6. So that is a sequence. So an algorithm can have a sequence. An algorithm can have a selection. So what is selection? So selection, again, the term selection is not new. It's a commonly used English word where at many cases we make a choice. We select 1 out of 10. We select 1 dress out of 5 dresses. We select 1 medicine out of 2 medicines. So for many reasons, using our intelligence, we select. In selection, a statement is made to undergo a point where a condition is checked. Based on the output of the condition, either a particular part is executed or another part of the program will be executed. So let me make it clear this way. If a conditional test is present and the condition is tested, and if it is found to be true, a part of the program will be executed. Otherwise, another part of the program will be executed. So let me give you a simple example. If a person is entering a railway station, there are a number of platforms in front of the person. A person has to identify which platform he has to go in order to board a particular train. So, based on the destination of the person and the train in which he has to board, he has to make his way there. He or she cannot be going to all the platforms. So, check for a condition and then select a particular platform. So, that is selection. So, the syntax goes like this. If condition is true, then perform action 1. Else, if condition is false, then perform action 2. So that is selection. So an algorithm can contain statements which are sequence in nature or selective in nature. So let's look at this example before we go to the third part called the iteration. Now finding the greatest number. Now there are two numbers A and B. I want to find out which number is greater. So there is a simple algorithm that is shown to you. Step number 1, start. Step number 2, read A. Step number 3, read B. So these two are inputs. What about step number 4? There is the selection, a condition being tested, which is shown in red. If A is greater than B, then 4.1 says print A is greater. Else 4.2 says print B is greater. And 5, stop. So here, this is how a selection statement is written in an algorithm. Next comes our iteration. In some programs, certain steps or statements have to be executed or repeated again and again based on a particular condition. So iteration, the word iteration is very, very important, and it is very common when it comes to any programming language. It is actually called a loop. A loop is nothing but a set of statements which are repeated again and again based on a particular condition. So the basic structure goes like this. Repeat until condition is true, and then a block of statements. It could be one statement, it could be n statements. So those set of statements will be executed as long as the condition is true. So every iteration or every loop, the condition will be tested. If it is true, yes, it enters the body. If not true, if the condition is false, then it exits the particular loop or the looping structure or the iteration. So let's look at an example for this. So now here you are asked to print values 1 to n. So n could be 5, n could be 10. So if n is 5, then 1, 2, 3, 4, 5 it has to print. If n is 10, 1, 2, 3, 4, 5 up to 10. So step number 1, start. Step number 2, read the value of n. It could be 3. Then prints 1, 2, 3. So that's our problem. So the problem has to be clearly defined and understood before an algorithm is written. So here printing the values one by one is an iteration. You have to do it again and again until the value n is reached. So step number 3, initialize I as 1. Step number 4 comes our iteration part or the looping part. Repeat step 4.1 and 4.2 until I is less than n. So what are the body of the statement? 4.1 and 4.2. So what does 4.1 say? Print I. What does 4.2 say? I is equal to I plus 1. So it increments. So the steps 4.1 and 4.2 are repeated again and again until the condition is satisfied. So what is the condition? As long as I is less than n. The moment I becomes equal to n, the condition is becoming false and step number 5 will be executed. So what are functions? So functions, let me just brief you a bit to know what are functions, and then these 4 are the important building blocks of an algorithm. And this will definitely help you in writing a Python code. So what are functions? Functions are subprograms which consists of a block of code and performs a particular task. So when you have a huge program, it is very much essential to break down these into small functions or subprograms and get your work done. So I am just showing you a very simple basic function for adding two numbers. So there is a main function which says step 1 start, step 2 call the function add, and step 3 stop. So step 2 calls a function called add. So let's see what's the algorithm of the add function. So the add function has step 1 function start, step 2 get a comma b. These are the two numbers we have to add. Then step number 3 is add c is equal to a plus b, which is an assignment statement. And step number 4 is print c, which is an output statement. And step 5 says return. That means that is the end point of the function. So it returns the value to the main function which called it. So it comes back to where it left. So step number 3 in the main function will be called in a sequence, and step number 3 says stop. The function execution gets stopped. The main function execution gets stopped. So we've seen 4 important building blocks. We've seen what is a sequence, what is a selection, what is iteration, and what are functions. So these 4 are the important building blocks of any algorithm. So given any algorithm, you should be able to write, given a problem, you should be able to write an algorithm very, very easily by making use of these 4 building blocks based on the problem that is given to you. So thanks for learning with me, and see you in another session with how algorithms can be represented. So what are the various notations that are there for representing the algorithms that we have learned. So thanks for learning with me. Signing off. This is Esther Hannah.